Well, that's a very tough act, tough act to follow, Victor. And I think what you'll find is that I'm going from a very different perspective, violently agree with almost everything that Victor said, almost. So let me just start by thanking President Leahy for the kind invitation for putting on this symposium, all the folks associated with the Urban Coast Institute, and also congratulate you on your 20th anniversary. And I know you're stepping down, but I can guarantee you've left just a phenomenal legacy. And Tom, you got big shoes to fill, but I'm sure you'll do it. And I wish you another 20 years of success. You asked us to talk about our motivation, and if I think back to my motivation, I have to admit, if I'm going to be honest, that it was a very, very selfish motive that led me into this work. I grew up in the Bronx, not Texas, closer to the ocean, but still I didn't see the ocean from where I was. And my grandfather had a little laundry in Manhattan, and when I was 5, 6, 7 years old, I'd go visit him at the laundry. And next door was a sporting goods store, and this is in the 1950s, and they had some of the very first scuba gear that was out there, the old double-hold regulators and the Lloyd Bridges type stuff. And I would go in there, just stare at it, and there was a book there next to the scuba gear, and my grandfather saw me look at it, and he bought the book for me. And it was a book called Boy Beneath the Sea. And it was about 2 young divers exploring the waters off Ceylon, what was then Ceylon. And I thought Jacques Cousteau had written the book, but I looked it up just a few days ago, and it turns out, amazingly, it was Arthur C. Clarke wrote the book. But I saw the book and the beautiful pictures in there, and I was in awe. That was it. I was gobsmacked, and I said, that's it. I was 6, 7 years old, and I wanted to explore and discover and see these beautiful things in the ocean. Now, no one in my family had gone to college, and I think they found this amusing, but blessedly, they didn't discourage me. They encouraged me. Actually, my grandfather actually bought me a little mask and snorkel, and I remember spending probably hundreds of hours in the bathtub on the 6th floor in our apartment, staring at that drain, but imagining I was exploring the ocean. I stayed focused on this. I discovered Jacques Cousteau. I found out that there was a field of oceanography. I traveled on the subways in New York in junior high school, going around to a number of symposia that they were having about oceanography in the 1960s. And each time I asked the people who talked, I said, where do you go to study oceanography? And I wrote it down in a little book. And when it came time to apply for college, I applied to Scripps and to Woods Hole and to Lamont. And I got nice letters back from them saying, sorry, we're not an undergraduate university, we're a graduate school. Now, again, nobody in my family had gone to college. I didn't even know the concept of graduate school at the time. But fortunately, Rhode Island was on that list, too. And I applied there, and they accepted me, and I did well. I had a wonderful mentor who allowed me to be a research assistant as an undergraduate. And eventually, I did go to Scripps and start to live my dream as an ocean explorer. So the motivation was very selfish. I wasn't thinking about saving the world. I really just wanted to do what interests me and to fulfill what I was passionate about. And I was able to hit the ground running. I worked for an amazing lab called the Marine Physical Lab. I think Admiral Gaffney will know about that, the early days of developing deep-towed instrument packages to do the first really detailed mapping of the seafloor. It was actually built to look for some lost submarines at the time. I started to travel. I'd never been on an airplane until my first graduate cruise. As Tony knows, I've not got off them since. But I started to really explore the world and the ocean and live the dream. So the dream really did come true, but along the way I learned something very important. I learned that the data I collected, that the analysis I did, served much more than my selfish passion. And I first ran into that when I was a first-year graduate student. I was visiting Woods Hole Oceanographic Institution. And on the walls of Smith Hall, they had these old letters framed, and each one had a little glass slide on it. And these were letters from World War II submarine skippers, written to a fellow named Brackett Hersey, who was an early ocean acoustician at Woods Hole. And each letter told a story about how they had used what he had taught them to save their lives, because he had taught them how to use the temperature difference in the ocean to hide their submarine. And I realized that the data we collected could be critical to the defense of our country, and that was a good feeling, and it could save sailors' lives. And as time moved on, and we began to recognize that we're facing increasingly severe environmental threats, I realized that it's the same data that saved those sailors' lives that are also critical to understanding environmental change and to modeling climate. And this is not just for the temperature data that the submariners and the climate modelers use. It's true for almost every data set that we collect about the ocean. Because the bottom line is that there's still so much more to learn about this remarkable ocean that provides much of the oxygen we breathe, the food we eat, it moderates our climate, and is a key component to national security. And so I contend that we still have a number of fundamental ocean parameters that we need to measure and understand before we can, with any degree of certainty, understand the complexities of ocean processes and thus capture the current state of the ocean and, more importantly, predict the states of the ocean's response to natural and anthropogenic change. And I think in that sense, we're in very close agreement. We just don't have the data yet to fully understand what's going on. That doesn't mean we should stop trying to do it. We have to keep trying to do it and making the best guesses we can, but we need more data. And if we look at the component of ocean data that both Victor and I have focused on, which is the seafloor mapping data, we find, as Victor said, well, I'll take a step back. You said we have 3/4 of the ocean yet to map. It was only in 2017 that after 100 years of trying to map the ocean, only 6% of the seafloor was mapped. And this is what I call the geospatial context. This is what every other measurement has to fit in, and yet we only knew 6% of the ocean. There have been a number of efforts, Victor's tremendous work to try to collect data. There's something called Seabed 2030 from the Nippon Foundation that have been trying to facilitate that. And since that time, the number as of yesterday is 27.3% of the seafloor is mapped. And I should say, and Tony, you mentioned that among that 27% is data we've been collecting over the last 20 years or so to establish the limits of what we call the extended U.S. continental shelf. This is how far the U.S. can have sovereign rights over the seafloor and the subsurface. And in that time, we've now mapped all that and have extended the U.S. territory by 1 million square kilometers. Admiral Gaffney said, "You make sure you say that." so I did, and I'm very proud of that fact. But it still means that, as Victor talked about, almost 3/4 of the ocean remains unmapped. Climate modeling depends on accurate maps of the seafloor because we need to know where bottom currents go. We need to know what the bottom roughness is. Both of that controls the dissipation of heat in the ocean. Can you imagine trying to predict the weather in the western U.S. if we didn't know about the Sierras or the Rockies? Same situation. How do we determine the distribution of bottom habitats without maps? How do we plan cables? How do we plan pipelines, build any sort of infrastructure? The bottom line is, how can we hope to operate in? How can we hope to manage, to understand, to predict what we don't even know? And so in our quest to secure this fundamental knowledge of the oceans, needed to understand current and future ocean behaviors, a subset of us, Victor and I and many others, have really focused on this idea of seafloor mapping data. Again, the data that provides the fundamental context for almost any other ocean data. You got to start somewhere, and if you don't know where you are and where it fits, what do you do with the other information? So I mentioned this Seabed 2030 initiative. It has worked very hard to raise the visibility of the need for ocean mapping. It's funded a number of efforts to locate a lot of existing data. There's a lot of people had just data in draws somewhere here or there. But to date, it really hasn't invested much in the collection of new data. Our federal government has recognized the need with something that's called the National Ocean Mapping Exploration and Characterization Strategy, which calls for the complete mapping of the U.S. extended continental shelf, not extended, EEZ, the exclusive economic zone, by between 2030 or 2040, depending on the water depth. But the U.S. EEZ is only a small part of the global ocean, and ocean processes know no boundaries. So we can't just say, well, we're just going to map this, because everything is connected. Sadly, Some of the most serious efforts to collect global ocean mapping data have come from philanthropic organizations like the Schmidt Ocean Institute, OceanX, and particularly Victor's wonderful efforts. And I say sadly, not because I'm sad you're doing it. I'm absolutely thrilled. It's one of the most wonderful things. But I'm sad because these data are so important that in my mind, we should not have to rely on the good graces of wealthy individuals to collect the data. And here's where you and I might differ a little. I think that is a fundamental responsibility of the government. Whether the mechanism of collecting it is a collaboration, which I totally agree with you, but I think it's a fundamental responsibility of the government to collect these critical data. Or maybe not just our own government, if we're talking about the world ocean, maybe a consortium of governments. Can we envision an international ocean mapping initiative that pools funds and assets to organize a global effort to map the world ocean? Let it be governments, private sector, philanthropies, all together. Much like the International Ocean Drilling Program. This is a remarkable program, 65 years, one of the most successful international collaborations ever, where funds were commingled to create scientific drilling all around the world to really answer fundamental questions about plate tectonics. And now we have the next level of fundamental questions about how the ocean works. If 10 or so developed nations would contribute something like $30 to $50 million a year or equivalent in ship time, might be even easier for them to do, we could have the world ocean mapped in less than 10 years. And if we can't organize an international effort, is this something the U.S. can do on its own? Admiral Gaffney, how many years ago did you envision GOMAP? A Navy effort to map the world. A visionary. Didn't serve as CNR long enough to make it happen because you're constantly rotating. But that was a vision. Can we think of this again? We estimated it would cost something like $3 to $5 billion to map the global ocean with current technology. Victor is working on some very, very cool stuff now that may make that much less expensive. But those kind of costs are the cost of a single mission to the moon or mission to Mars, as Victor mentioned. And I'm thrilled we've sent missions to map Mars and the moon and now Pluto, as you say, and mapped much better resolution than our own planet. But perhaps it's time to really think about creating a mission focused on our own planet, pointing our senses inward and creating a mission ocean map. Now, these are difficult times for funding, but as I've pointed out, these fundamental ocean measurements have many, many masters, serve many, many masters across all political persuasions. There's very few sides of any political argument that can't argue that these fundamental measurements serve some important purposes, whether it's national defense, environmental studies, whatever. And so I'm hoping, and maybe through mechanisms like Victor described, we'll have a chance. Thank you.